In this video, I'm going to talk about camera. So in camera, the basic elements of camera are, the first thing is lenses, a light tight box where light cannot enter into the inside the box, a shutter to let light pass through it briefly, and electronic sensor, a piece of film. These are the basic main four parts of a camera. Now, how do you define this is a good camera, or it takes good pictures? So based on these three, those are called exposure time, how long or how fast the shutter is closing and opening, that's called exposure time, and f-stop or f-number, focusing. Exposure time is nothing but it refers to how quickly the digital sensor can make an accurate reading. Okay, that's called exposure time. F-stop or f-number is called, it indicates the amount of light reaching the film. That is called f-stop or f-number. It indicates the amount of light reaching the film. So the f-stop or f-number, both of them are same, is equal to f, which is focal length of the lens, divided by the diameter of the lens opening. This is the formula for f-stop. Now, zoom lens. Typical cameras have the object, distance of the object is greater than 20 centimeter. They can take good pictures if the object is 20 centimeter away from the lens. So I'm using D0, but probably your textbook might be using D0 equal to S and distance of the image equal to S prime. So don't get confused. So usually distance of the object is a lot greater than the focal length of the lens. So this leads to distance of the image is approximately equal to the focal length. So for a good camera, distance of the image is approximately equal to the focal length. Magnification, we know that M is nothing but minus di by d0, which is, if I take di equal to f, focal length, which is minus f over d0. So we know that magnification is proportional to the f. So size of the picture, size of the image is going to be proportional to the focal length. Now, the light intensity. The light intensity indicated with I is proportional to the d square. D is the diameter of the lens opening. Okay, I is also proportional to 1 over f square. F is the focal length. So basically from this, I is proportional to the d square over f square. We know f number, we just defined f number is nothing but f over d. So this is in reverse. So I can take this as intensity of light I is proportional to 1 over f number square. Okay, f number square, that's what it is. Now, exposure is nothing but the total light reaching the detector while the shutter is open. So this exposure is nothing but I, intensity of light, times delta t. Okay, so remember this, we're going to solve the next example based on this. A camera takes a properly exposed photo with a 3 mm diameter operator. Aperture is nothing but the hole, and a shutter speed of 1 over 125 seconds. Shutter speed is given, which is delta t is given. What is the appropriate operator diameter for a 1 over 1000 second shutter speed? So if the shutter speed is 1 over 1000 seconds, what will be the size of the hole? Basically, that's what he's asking for. So the exposure, we know that I, intensity, times delta t. I is proportional to d square over f square. So basically we have two cases. Okay, if the hole size is 3 mm and shutter speed is 1 over 125 seconds, then what will be the hole size when the shutter speed is 1 over 1000 seconds? So based on this, And remember, we are using the same camera, so the focal length must be same. So I times delta t proportional to d square over f square times delta t. Okay, so if I take those two conditions, one is d1 and another one is d2, so d2 square, which is the new new whole size, equal to f2 over f1 whole square delta t1 by delta t2 times d1 square. Okay, all I did, I equate these two equations basically. Okay, so d1 square over f1 square delta t1 must be equal to d2 square, sorry, delta t2 times d2 square over f2 square. Okay, I know this value, I know this, I don't know f1, but at the same time f1 and f2 are same, they cancel out each other, so d2, so find d2. So based on this, I found d2 equal to 8.48 mm. Okay, this is all about camera. Thank you.